All right, welcome to a series here on the workflow from Mixamo to Maya to Unity. There's some things here that I'm doing that are probably a bit out of the ordinary, but it's just to fit my particular use case here, as well as having to figure some of these things out myself. I may have not found the best solution, so by all means, like in the comments, if you have some different ideas, put them down there, or if you have any questions, feel free to ask. I'll try to answer them. So in this circumstance, we already have our game geometry. Sort of the purpose of this workflow is to create a non-destructive workflow so I can change this model and it won't mess anything up that happens further down the pipeline as we get into Unity and things like that. So I have my character geometry here. It's got quite a few faces, but given modern standards, like it should be fine. One thing that's important to do with your bipedal characters, you want to move your origin point, your anchor point for your model to 0, 0, 0 in world space. In order to do that, with your model selected, you select your move tool, and you hold down the D key, and that's going to bring up your anchor point, and you want to move that down to the origin. Once you have that, you want to freeze your transformations. You do that by going to Modify and Freeze Transformations. And you also want to delete all of the transformation history, actually all of the history at all. So you go down to Edit, Delete by Type, and History. That's going to make, it just removes a lot of additional information that gets attached to the geometry and ultimately saved. So things like rotations and transformations can actually be stored to the model, which will then really upset things down the road. So now that we have that clean geometry with its anchor point at the origin, we can export this model. All right, so we have to export this geometry as an FBX. So if you go to File and Export as Selection, it brings up your export options. You're going to want to export the smooth mesh, and I would suggest changing the FBX file format. If you run this back down to FBX 2013, it'll be a lot more compatible. You can also set your project in here so that all of these folders actually update to your Maya project, which makes it a little easier. You're going to be going back and forth here a lot. So yeah, pick a file name. In this case, I'm going to call it Fire Enemy Model. And this will be the Maya export. And export selection. So that's going to generate our model, which we're going to upload into Mixamo for the sake of rigging. You can see I already have them rigged here, but we will redo that step. So here's my file explorer, and we have our assets here. So upload a character, and it's just a simple drag and drop. And here's the one that I just created. And it's going to process for a moment. And this brings us to the auto rigging tool. You make your way through here, and it allows you to select some locations so it knows where to place the bones. So I put a chin right at the bottom of his chin. You do the wrists and the elbows right in the crease. Pretty self-explanatory. Same with the knees. And then the groin, I always put the groin a little bit above, so it's like that's where the hip will be and the leg bones will connect. You want to leave symmetry on so it winds up nice and symmetrical. And it's then going to generate that rig. Bear with me here, I'll sort of keep talking so it's not dead air. I will be uploading this to YouTube, so maybe somebody will watch it in the future. I feel like this was quicker the previous times. Sometimes the page is a little slow. All right, there we go. So you can see It auto-rigged it. You can tell the animation looks like it's working properly on this model, so we can continue with the process. It then wants to save this model to your account, and it gives you a dialog because it'll overwrite a previous saved model. And that's really important because you want all of the animations that you export to sort of go to the same setup of the model, so that it'll be universal on your imports to whatever software that you're using as well. So the next step, now that we have that, we need a T-pose. So you can just search for the T-pose up here, and this is the T-pose. You can see that maps well to our character. Everything's fine there. And that's really all we need. So we can download this, and some of these settings here are rather important. So you have frames per second. Here you want to select 60. This is because we actually lose all of the artist keyframes that were originally in this animation are gone. So what this is essentially doing is breaking this animation up into little segments frame by frame. So the higher you can do here, essentially the more resolution you have to the animation. For instance, if you want to really stretch this animation out over a long period of time, say 300 frames for some reason, a slow build-up, you want to maintain as much of that resolution as possible. In this case, we are going to export it with the skin. Some of the animations in the future, we will probably be exporting them without the skin to save file size, because all we'll actually need is the animation data. And we don't want to reduce the keyframes. Yeah. So we're going to download this. It is possible to download just segments of the animation, and that's something we'll be doing in the future. This doesn't actually have animation, so I don't believe that option was there, but we will want to split these animations up into segments so that we can adjust timings and things like that. That's about as much as we can get out of this. So here's my export. And so I'm going to drop that in my folder with all my other stuff, and I'll rename this to Fire Enemy Rig Mixamo export. Now, you may not need to, go to this extent naming it, but I've kind of done this process over and over to get it right, and just to be sure that I don't mix up my files. I'm kind of going with a bit of a more elaborate naming convention. So now that I have that, we should be able to load that back into Maya. I'm actually going to save this scene and start a new one. And let's see if Maya crashes. This is one of those times that, yeah, there we go, it crashed. For some reason, it doesn't like creating new scenes. So we'll do that from scratch here. Bear with me while the software loads. And we're in. Look at the size of that error panel on this ultra wide. I'll close this error panel. Okay. So we're basically in a new default scene here. So we can now import that animation. We could just click on import, go to our assets folder, and there it is, Fire Enemy Rig Mixamo export, and you want to import that. I like to check over here and see if there's anything of importance, but I don't think we had to change any settings there. Okay, here we are. So it came in, and you'll notice the bones look a little wild, and that's actually because the default model size in Mixamo is kind of gigantic. So what you can do to change that is you go to Display, Animation, Joint Size, and you could just scale this back, and that'll sort of change the display size of the bones to something that makes a little bit more sense, where we could see what's going on. I'd say 0.08 will work in this case. Now, when I modeled my character, I made him, I thought I made him 6 units tall because I'm stupid American potato, and those were represented 6 feet, but it looks like I'm actually at 10 here. I'm not sure why. I'm guessing this may have been the default export size from Mudbox, but the reality is that's all sort of arbitrary because you froze the deformations, froze the transformations and stuff like that. That will allow them to scale it in Unity without it really messing anything up. So some things that'll make these next steps a little bit easier. If you have any of the panels highlighted, you can just press space to go full screen. I would suggest turning the bone view on. Hopefully you can see where my mouse is going. It's right at the top of the panel, X-ray joints. That'll allow you to see the bones through the model. And then up at the top here, select surface objects. I deselect that. That way you can click on the bones and you won't accidentally click on the model itself. Now over in your hierarchy, the outliner here, you see we have the model, and then we have the rig, which was generated by Mixamo. Now what we have to do is get this set to a way where whenever we load a animation from Mixamo, it'll map to this skeleton. But even more importantly, when we export this and import it into Unity, the Unity recognizes it as a rig and whatnot as well. And there's some modifications that we have to make to this to make it a little bit more, I'll call it game friendly. We need like an origin, because right now the top of the hierarchy for the skeleton is this hip, which is at the center point. But that actually creates some problems because we want a root node that's at 0, 0, 0, 0, 0, I should say, 3-dimensional, so that it can act as sort of the point where the character is on the ground, and it becomes the ultimate control point for which all of our programmatic controls and things actually control the character, rather than controlling him from this center point. And you can sort of think of that because this character, if you imagine as he animates, is going to squish in all axes, but particularly in the vertical axis. And so this origin point kind of becomes useless. All that really matters is where his feet are. Yeah. So we have this, and our next step here is to create a control rig, and then we can save this control rig as a template, which then can be added to any other animations that we bring in from anywhere, even if, for instance, the file naming structure is different for the skeleton, and that's sort of the struggle here. You can see there's a naming convention that was used. And you may have a different naming convention on your model, and you need to make that in some way, shape, or form universal. So the way we go about that is actually in this panel over here, which resides under Windows Animation Editors, Human IK. All right. And that'll bring this up. And what we have to do for this is create a control rig. And that brings up this here, where we need a definition for the rig, and that's exactly what we're going to do, is we're going to define that. And so now in this panel over here, you can see what resembles a normal bipedal human skeletal structure, which is a sort of universal rig, which this is the kind of thing like Unity is going to understand this as well. So you could, for instance, after doing this, create animations right in Unity and not have to go all the way back to this 3D editor program. It's one of the things that sort of helps create a non-destructive workflow. So all we really have to do here is map all of these control points to actual bones, and that's done pretty easily. All you do is you double click on a node here, and you'll see it highlight, and then you click on the corresponding bone. Yeah, and that about sums it up. It's even smart enough where it'll handle the mirror images. So you'll see it automatically mirrored the other leg. So what I'll often like to do, I'll go back in and check the other side just to make sure that its decision-making process was in fact correct. There are flyouts here. For instance, on the hands, you click on this and you can go in and do the whole hand in detail as well. So those are things that we'll need to do also. So you click on the foot, that's the bottom foot part here. The upper arm, lower arm, the hand, and then go into the actual hand here. Now this is a time where I'm going to actually change that joint size again to make this a little easier to read. Yeah, 0.01. Now I can really see those bones in there. And so 1, 2, 3. Yeah, so this corresponds to the next bone in the thumb. Next bone of the thumb. Now it's doing this thing where it's showing you, because you're in the flyout and you can't see it all at once, it's going to the other hand and showing you that it mirrored it. So to play it safe, I always kind of pop back out and go into the hand that I'm actually working on. Click on the next thing. Yeah. Then there's a fingertip, which is actually the joint at the end. Yep. And you just make your way through and you complete the hand. It doesn't take all that long, but it is definitely a little bit of work. And this is something you don't want to have to repeat every single animation, which is why we're going to create a template where it's going to recognize that default naming structure that came out of Mixamo, and we'll be able to just apply that template to every animation that we bring in. Yeah, and so pretty easy, but time consuming. You'll see we have some other flyouts we have to do as well. There's one for the spine, one for the neck, and there's one for feet. In our case, they're not nearly as involved as the hand, but if you had a more sophisticated model, it could perhaps be just as involved, because you could do every single vertebrae if you so chose. Not really a requirement, I would say, for gaming, but maybe in some other application that may make sense. Thank you for bearing with me. I know this is a bit time consuming. And the pinky joint. Okay, so now, yeah, it looks like that all mapped correctly. Like I said, I like to then check. So I just sort of, if you click on a bone, it'll highlight in the scene. I just sort of make sure that the corresponding things actually highlight, that this is the correct hand and such, and that it didn't randomly map a bone from the other side, because I have had it do that. All right, now I'm going to jack my bone size back up a little bit. Joint size, I mean, back up to 0.08. For the sake of doing the rest of the body. So we've got a head joint here. And yeah, that's about it for the basics. So there's a few more flyouts. We have to do the spine. So that's going to be the first joint in the spine above the hip, which in this case would be this. All right. Now, when you go into the flyout, you can see you have more vertebrae. This one will be the one above the base of the spine. So you already selected the base of the spine. Spine 1 will actually be the next joint in the spine. All right. Now you're going to go all the way up until you meet your shoulders. And this is sort of one large bone that affects all of these. So I skip right over that and say, okay, that's the end of the spine. And you have that mirrored at the neck. So everything that's sort of above that shoulder intersection would be considered the neck. So, and you again start at the bottom. So neck 1 would be this bone. If you had multiple neck bones, you'd keep working your way up, but the head is the next bone up. So there's only actually one bone in the neck. And all that leaves is our feet. And so if you go down to the feet flyout, This actually represents the toe bone, and in the case that you didn't bind every single toe in our foot, which we didn't, because we're not going to actually have toes, we're going to have boots or something like that. So this just sort of represents that. Oop, that was not correct. This just sort of represents that whole toe bone. So there we go. So you want to make sure that you got that on both sides, and that, you know, it's selecting the correct okay, so it looks like it actually mapped the wrong side, which is why I always check. Do you want to change? Yes, I do. Okay. And then let's make sure the flip side. Yeah, okay, so now we got that right. That one selects that one. This one selects this one. All right, and yeah, that's the entirety of the default model. Now there is a bit more to this that that we're going to need. I mentioned that control point. I am going to save this scene, make sure I don't lose everything, and my scenes folder. So now we're going to call this player enemy model and rig. Save. All right, it didn't crash. Okay. So for the next step, we need to create that sort of, as I mentioned, like a base bone. It's certainly not a requirement for every game situation or whatever, but I do believe personally that it makes that it'll make it easier in my particular use case. Because that's how I set things up for a previous character with my scene, so they'll understand that language. And so if you're on your animation tab, you're going to need to go to your rigging tab, and there you can create joints. I'm going to create this in the front view. Boom. And I want to snap that to the grid so that it's at exactly 0, 0. In order to do that, you hold X. Well, first you have to select the Move tool. Hold X, and you'll see the center of the widget turn to a circle. That's the snap to grid, and you'll move it with the middle mouse button. That'll allow it to snap, and you can see we got it right at 0, 0 now. Awesome. You can see that created joint 1. I'm going to rename that to match the naming convention. Probably doesn't make a difference, but you know, you become sort of OCD about these kind of things, and I'm essentially calling it root. Now we're going to need to parent the rest of our skeleton to that. So I'm gonna you click the child first, which in this case will be the hip, which will be the entire skeleton, and then secondly you select the parent, and you just press the P button to actually parent them, and you can see now you've got this large bone that goes from the origin to the hip, and so that bone will allow us to control the character model from the origin rather than from the hip. And so that'll directly move things. I'm going to save the scene. Yes, okay. And that corresponds in the rig to this here. So you double click this root bone, and then click the root, and that'll map. And then I always sort of double check, like I said. Okay, there we go. Now, for the next step, the issue that we have is that Mixamo's already skinned this mesh to the skeleton. So that root bone that I just created isn't part of the skin. So when I go to export this FBX, the FBX won't be smart enough to understand that information without us sort of reskinning it. So to do that, we have to reskin this character, and it'll remember all of its skin weights and stuff as long as you don't delete the history. So what you have to do here is go to display and unclick DAG objects only. This is going to show the entire hierarchy, which is like a lot of stuff. These are all the different data points. And type in star bind star, enter. Now this is the binding parameter. And we're just going to highlight this and delete it. So now at this point, the skeleton is no longer bound to that model, but all the correct binding data for this particular geometry is still stored there, as long as you don't remove the history. Now go to display and turn the DAG only back on to get rid of all of those control points. And now basically we have this skeleton, which we have to rebind to the model. So we're going to do that via mel script. Bear with me a second while I look that up. All right, so you're going to want to select your skeleton and your model. And the command we're going to type down in the mel script window, which is at the bottom here, which allows you to enter scripts. You can actually do some pretty sophisticated things. I've even seen games made in this once upon a time. Is DAG pose camel case parameter S parameter bind pose. So that's save bind pose, hit enter, and result. The pose is bound. Excellent. So I'm going to save this scene again. Continue. And we can now export this. So I'm going to delete the time editor just in case, because I don't think... Yeah. Select your two things, your model and your skeleton. And we're going to go to export selection. And much as I mentioned before, I like to keep that at 2013 under the binary. And at this point, the smooth mesh is also attached. We will be unchecking that when we export just animations. All right, so we're going to assets, and so now I'm going to call this model and rig. As a Maya export and export. And look at that, it worked. You would have gotten an error if we hadn't have done that bind and unbind. So next we got to go into Unity. And all right, this is where I'll be storing my models and animations. You know, we sort of have like a little test lab folder, so that as we're doing work, it doesn't interfere with the overall structure of the game, and then we can sort of create our prefabs and things from these test folders to actually import into our game scenes. So this is my character testing scene, and then I'm storing my assets in here, my animations and models separately, just for the sake of keeping it straight in my head, if that makes sense. So if I go to my asset folder here, you can see we've got our Maya fire enemy model and rig from Maya, which was the one that we just created. You drag that into here, and it's going to do our Unity's fancy import. And you can see it has a bunch of nodes. So it has the model with a default material applied, which was created in Unity. So you could go further with that. You know, this default material could be a whole series of UV with your shaders and so on and so forth. You have the skeleton starting at the root node, as I had created it. Here's the actual geometry for the model. There's an animation for the skeleton, which in this case is defaulted to take 000 or 001. That's our T-pose. And then you have this avatar. So you'll see in our future imports that this animation will actually, you know, sort of pull that out of there to use it in an animation controller. But if you were to drag this into the scene now, we got our fun little character down there. I'm going to put him at location 000. Yeah, so there he is. He's in there. He's got his skeleton. He's got his animations, which is a good starting point. You can see over here is where you would add an animation controller for all of the animations in your inspector when you have him highlighted. yeah, so we'll start there, and in the next episode here, I'll be adding an animation from Mixamo to the character. All right, so now we're going to attempt to add Mixamo animations to this rig and model and export those and get those into Unity as well. So I would suggest this defined control rig that we created over here. You want to actually save this, and it has a save and load option here, so we save this skeleton definition. It's a template type, and this goes into your Windows user folder as sort of a global thing that you can access from any of your scenes. So I suggest keeping it in that original folder there, and you can name this whatever you like. So in this case, I'm going to call it my fire enemy underscore control rig. Actually, I'm just going to call it rig. Yeah. So that'll save to that folder. In my tutorials, we may not wind up using that, but that's great if we bring in a Mixamo animation or something where by chance that skeletal structure is named differently. We can just load it here and reapply it, which will be beautiful. All right, so if we go over to Mixamo and find an animation, here I already picked this run animation that we're going to add to the model. I do see some problems with this for game purposes already, but I think it'll make for a great example. So we're going to download this animation that I chose. This was the Ninja Run one. You can see it here. And again, we're going to do it in FBX format. I already explained the 60 frames per second. And in this case, we're going to do it without the skin. Because we don't need the model. We already have the model, and we're going to be reapplying this to the model. All right, so if we download this, all right, there's our run FBX. I'm going to transfer this over to folder where I'm storing my assets within the scene, and then I'll rename it to match my file structure. All right, so I'm going to call this fire enemy run, and this is a Mixamo export. Great. So now we have that run animation. If we come back over here where we have our control rig and whatnot, all right, so now we're just going to import that animation to our existing rig and model here. So if we select our root for our skeleton, go to File, Import, go to our Assets folder, you'll see that Fire Enemy Run Mixamo Export. Highlight that, click Import, and you can see that it mapped that animation directly to our rig, and if we hit play, you can see it's playing. It is running rather fast, but that's because we're at 60 frames per second. We only have 38 frames here. That's something that I'll smooth out. We can, go through this frame by frame. And you can see the problem here that I saw with this animation. I'm not sure if you're aware, but since this animation is actually moving away from its origin point, you figure this origin point is where our programmers are going to be controlling the character from. So we don't want it to actually physically move in the world space, in the animation. We want that to be controlled by you, the player. So we want to keep the character animation in terms of its leg movements and arm movements and such, but we want it to stay at the origin point. So that's what we'll be doing with this particular animation. Now, not all animations are going to require that. Some of them will already be in place. And you can see we got our 38 frames across the bottom here. We've got our model, which is now skinned. It's still skinned to the same skeleton, but it has this animation applied to it. Now, it generated some errors over here, but it's nothing to worry about. Everything is working pretty much as intended. All right. So if we select, rather than our root bone that we generated, if we select this hip bone, this is where the animation begins, and you can see these red ticks in our timeline. That's the motion and rotation and whatnot of this hip bone. You'll notice when we select the root bone, there is no animation, and that's because we added that. And there's no defined animation for that in this particular Mixamo animation. You will see some of them that do. It would have been beautiful if this character moved based on a root node, because then we could just move that root node back to the origin, and he'd run in place, and it would solve our problem. But in this case, it's actually the hip that's moving, separate from the root. So in order to fix this, to have him run in place and have that movement controlled by us, the player, we have to then actually keep this hip bone at 0, 0. As I suggested probably in a previous portion of this video, you want this on X-ray joint so we can actually see right through there. So what I would do, in this case, we select this hip bone. It is selected. We want to move this to 0, 0. And that's in the X and Z axis, because this model will move up and down in the Y axis, but that's its natural bounce. So we want to maintain that because that's going to be in comparison to the root bone, which will stay at 0, 0. So all we have to do is snap this then to the grid in the X and Z directions. And to snap, if I didn't already say so, you hold down X. Well, you have to have the move tool selected first off. You hold down X and you'll see the widget turn to a little circle. That means you're in snap mode. And then you actually just move it with the middle mouse button. And now it's snapped at 0, 0 in the X and Z axes. You can see in the Y-axis it's still free. And so that's what we have to do now is go through frame by frame and move that to 0, 0. Every time we do that, we have to create a new keyframe for the hip to overwrite the previous hip keyframe. And to do that, it's just the keyboard shortcut S will save that keyframe. You can also do that via the menus at top. All right. So from the top view, I'm going to go through frame by frame. You can see there it moved. I hold down the X button. You can see it turn to a circle, middle mouse button, and move it back to the origin, 0, 0. And then S to save that keyframe. So unfortunately, we're going to have to do that 38 times in the case of this particular animation. But it's going to save a lot of headaches. I've seen other solutions to this where they, for instance, animate the origin point to counteract it, but I think it seems silly to have two separate animations that are fighting against one another just to make a net result when you can actually just clean this up. But that's sort of the beauty of bringing this into a 3D software editor rather than doing things perhaps right in Unity. It gives you that flexibility. It's unfortunate that Mixamo's setup doesn't, or at least I don't know how to access the original artist keyframes that have the tweening and whatnot on them. If you've done some animation there, you'd know what I'm talking about. It would make this workflow substantially easier to just be able to go in and edit those animations. But, you know, that's the trade-off you're getting for using someone else's animations, which is going to save you ultimately a lot of time. Maybe a little bit more time on the upfront in the pre-development phase to get everything working and with your particular use case, which is sort of what we're going through now in our project. But hypothetically, in the long run, you're going to save a lot of time because then you don't have to actually create all these animations yourself, which is definitely a lengthy but enjoyable process. But we're doing this in the scope of a collegiate school project, so we only have a semester to work on this, and unfortunately we don't really have the time to, you know, create all of our own animations. So thank you for bearing with me. I'm probably about halfway through the animations. 7 and 100%. What you're going to want to do once you get through and you key all these frames, you want to go back to the beginning of the animation and you want to check to make sure that you didn't accidentally forget to key one of those frames, because then he'll jump across the board. So I traverse through it one frame at a time and make sure it should look like he's running in place, which will now actually create a smooth looping animation as well. Yeah, it looks like it worked. I'm curious how it wraps around from the end to the beginning. So it looks like frame 0 is the same as frame 38, which is another potential problem. Well, rather than potential problem, it actually is a problem. So we need to remove that frame from our animation. I think we can just simply write 37 here, and that's going to shrink our timeline. Yes. Okay. Yep. So now if we hit play, it's a smooth animation, but it's running way too fast for you to be able to tell. So now that we have this, we want to save this scene as well. The reason being, we may need to go in and edit this animation again. There are a multitude of animation tools within Maya, which will give us a lot of flexibility. So rather than just jumping straight to exporting, I would definitely suggest saving this as a scene. In our scenes folder, fire enemy run, save as, replace, yes, yep. Okay. So now we want to export again, file. We want to export our selection, so I would select just the root node here, file, export selection, and now we can uncheck the smooth mesh because we don't actually need any geometry, and that's under the include subcategory on the export. We do definitely want the animation. You can bake the animation. That does allow for some different things as well, but at the moment, at least in this test run, that will not be what I'm doing. So at assets, we're going, I'm going to call this one fire enemy run. And in this case, it's the Maya export. You'll notice I keep saying all that, but that's really so I can tell the difference between which one is my download and then which one's my, so I know which one I need to bring into Unity. All right. Looks like that exported successfully. So if we go back into our Unity scene, where we have our guy here, we should then be able to just drag and drop and import that new asset. So we have fire enemy run Maya export. And I'm going to drop that into my folder. And you'll see that hierarchy has a bit less in it now. It doesn't have the model attached because I changed the FBX include options. But we don't need all of this stuff anymore. All we actually need is this component right here. This is the animation information. That exported the skeleton again, which we already have in this. And so all we need is this animation, but there's no good way that I know of to just pull that out of there, and it's got a silly name. So I duplicate it. Edit, duplicate. And then we can rename it. In which case, I'm going to call it fire enemy underscore run. And then I'm going to move that to my run folder, or to my animation folder. So if you drag this animation onto your model, it creates an animation controller. I'll go into this a bit more in a future video when I do the substates. But the important part sort of is that if you click on the model, that now applied that controller here, which before there was not one. I'm going to rename this because it doesn't exactly say what it is. I just want to call this player enemy animation controller, so that I'm more aware. Makes it a little cleaner and easier to keep track of things. But now what that's going to allow is me to actually test this. So if I hit play, the character should animate. Yep, and we see he runs, but it only ran once. So if we go into the animation here, you actually have the option to loop it, and that's in the inspector when you highlight the original Jimmy Jammy. Now when you hit play, yeah, you can see there we go. It's a full run cycle. So that's the whole workflow of getting the animations from Mixamo into Maya and then ultimately into Unity onto your model. And you can just stack these animations and save them in your folders or whatever, and then you can implement them programmatically or via this animation controller. In the next stage, I'll sort of do a split up sub animation, as I mentioned, and then I think that'll be the end of the series.